Hi, welcome to my video on part 4 on solving more inequalities, and this is number 1. We're solving different types of inequalities. Number 1, solve the absolute value of x to the fourth, subtract 8, absolute value of x squared less than or equal to 9. So I'm going to let the absolute value of x equal a. So that's a to the fourth minus 8a squared less than or equal to 9. So that's a to the fourth minus 8a squared minus 9 less than or equal to 0. And this is x to the a to the fourth. So, and we got a square here, so let's see if we can factor. A to the fourth is a squared times a squared. The factors of 9 to give me an 8 is 9 and 1. The product is negative 9. The sum is negative 8. So that's a negative 9 plus 1. And because this is factored, I can say that a squared minus 9 is equal to 0. And a squared plus 1 is equal to 0. So we can go with a squared equals 9. Square root of a squared equals plus or minus the square root of 9. So a is equal to plus or minus 3. And over here, a squared equals negative 1. Square root of a squared is plus or minus the square root of a negative 1. So the square root of a squared is a, plus or minus, and the square root of a negative number is an I, and square root of 1 is 1, so it's a 1i. So what we have is that a is the absolute value of x equals 3, or the absolute value of x equals negative 3. And the absolute value of x is equal to plus or minus I. Let's deal with this one first. These are imaginary numbers, so can't deal with that. We're only dealing with real numbers. The absolute value of x is negative 3. And that's a no, can't deal with that because the absolute value is always positive. So that means the absolute value of x is equal to 3. So that means x is equal to plus or minus 3. So we take the plus or minus 3 and put it on the number line, 3 and a negative 3. And we work out what numbers we're going to deal with. 3 and a negative 3, so let's try a 4. And a 0 and a negative 4. So if we take a 4 and plug it in, so let's take the negative 4 first on this side. Negative 4 subbed in here. We got the absolute value of a negative 4 to the fourth minus 8. Absolute value of a negative 4 squared less than 9. So negative 4, absolute value of a negative 4 is 4, so that's 4 to the fourth minus 8. Absolute value of negative 4 is a 4 squared less than or equal to 9. And 4 to the fourth is 256 minus 8 times 16 less than or equal to 9. 256. And 8 times 16 is 128, less than or equal to 9. So 128 is less than or equal to 9. So that's a no, that's false. So let's look at x is equal to 0. If x is 0, the absolute value of 0 minus 8, absolute value of 0, less than or equal to 9. So the absolute value of 0 is 0. To the fourth power is 0. Absolute value of 0 is 0. Square root is 0. Negative 8 times 0 is 0. Less than or equal to 9. 0 is less than 9. That's true. So we have, notice it says less than equal to. So that means the 3 and the negative 3 and the 3 are included because they got an equal to. So we're looking at these numbers in here. And if we try, when we have x is equal to 4 and 4 behaves, so if we put 4 in, we're going to get the same answer for 4, because the absolute value of 4 is 4, that gives us 256. Absolute value of 4 is 4 squared, 16 is 128. And so we get 128 is less than or equal to 9, and that's a no. So the answer to this problem is -3 less than or equal to x less than or equal to 3. Or we could go square bracket -3 comma 3 square bracket, because it's equal to. So these are values of x. So any values of x between -3 and 3, including -3 and 3, will fit into this inequality. Okay, let's try another one. This one's a little bit different. So what we'll do here is that we'll 4 over x minus 3 is greater than 2. So we'll go 4 over x. Oops, I'm going to do the 3. X minus 3 minus 2 is greater than 0. And so 4 over x minus 3, subtract 2 over 1. Make the 2 over 1. So in common denominator, for it's only one fraction, so the LCD is x minus 3, so we'll put an x minus 3 on top and bottom to make it equivalent. So we have 4 over x minus 3, subtract 2 times x minus 3 is 2x minus 6 over x minus 3, and so that's 4. Common denominator is x minus 4, so that's a 4. And we're subtracting, so that makes that a -2x plus 6 greater than 0. So that gives us -2x plus 10 all over x minus 3 is greater than 0. So if we let -2x plus 10 equals 0, -2x equals -10, so x is equal to, divide by -2, we'll get a 5. But we also have to look for, be careful of x minus 3. X minus 3 cannot equal 0. So that means x cannot equal 3. So we cannot have 5, or we cannot have 3. So let's check some numbers. Let's try a 6, let's try a 4, and we'll try a 1. So try a 0. I'll put down 0 instead of 1. So if x is equal to 0, so we got 4 over, put a 0 in, 0 minus 3 is greater than 2. So 4 over -3 is greater than 2. So -1 1/3 is greater than 2, and that's a no. So we can't take the numbers to the left of 3. And what about x equals 4? So 4 over 4 minus 3 greater than 2. So I'm putting 4 in the place of x. So that's 4 over 1 greater than 2. 4 is greater than 2. That's okay. So we're taking the numbers in between here. And there's no equal sign, so this is a hollow dot. And this is hollow because there's no equal, and we can have, so any value of x between 3 and 5 will fit. And let's look at x equals 6 just to make sure. 4, 6 minus 3 is greater than 2, so 4 all over 3 greater than 2, 1 1/3 greater than 2, that's a no, so we can't shade here. So the answer is 3 less than x less than 5. And again, it's no equal sign, so it's a round bar 3 comma 5, and you have a square bar if these are equal to, but there's no equal to, so it can't be equal to 5. So take any number between 3 and 5 and it'll make this inequality true. So notice we moved the 2 to the left side and we worked with the 0 on the number line. And don't forget, you cannot have 3 because 3 makes it undefined. Let's look at another one, a little bit different. It's x plus 1 less than or equal to 3x minus 1 less than 2x plus 3. So we go x plus 1 is less than or equal to 3x minus 1, and 3x minus 1 less than 2x plus 3. So notice there's an and here, and because we're looking for the numbers that will fit in this inequality with this one, so there's an and between these two. So we solve this. X minus 3x is less than or equal to negative 1 minus 1. Negative 2x is less than or equal to negative 2. Divide by negative 2, x is greater than or equal to 1. And the and keeps coming down for every step we do. So this is 3x minus 2x less than 3 plus 1. And so x is less than 4. We have an and. Now we have x's. I'm going to look at the number line. We have a 1 and we have a 4. So here it says x is greater than or equal to 1. So x is equal to 1 and greater. Right here it says x is less than 4 but not equal to. So it's a hollow dot, and less than is to the left. So and means what value will fit in this one and in this one. So that is right here. So it's an overlapping. So what we have is 1, and notice that 1 is solid, so 1 is less than or equal to x is less than 4. And that is solid bar 1 comma 4 open bar. And that's one way. You can do it by the graphing and see the intersection, because and is the intersection between what numbers are greater than 1 and less than 4. So, and that's these right here. Another way to look at it is to put a 5 here, and put 3 here, and put a 0 here. So if you put 0 in the inequality, if you take x is equal to 0 and sub in, I'm going to put a 0 in here, I get 1 less than or equal to. Put a 0 here, I get a negative 1. Put a 0 here, I get a 3. So 1 is less than negative 1? No. So we can't take the numbers to the left of 1. And what about when x is 3? Take 3 and put it right here, I get a 4. Less than or equal to. I put a 3 in here, I get 9 minus 1 is 8. I put a 3 in here, I get 6 plus 3 is 9. So 4 is less than 8, less than 9, that's okay. So you can see that the numbers we're using is between 1 and 4 and equal to 1. And finish it off, let's try what a 5 is going to do. Put a 5 in here, we get a 6, less than or equal to. Put a 5 here, we get 15 minus 1 is 14. And put a 5 here, we get 10 plus 3 is 13. 6 is less than 14, but 14 is not less than 13, so that's a no. So you can do the graph and shade in the intersection like this and pick up those numbers, or you can go with on the number line 5, 3, and 4 and see what fits. Okay, and this brings us to our last problem. This is a good problem to work out. Complete, again, is different, but it's an absolute value. So what I do is, again, is very similar to number 3. 1 is less than the absolute value of x plus 4. Again, there's an and, because what value of x fits this inequality right here and fits this inequality here. So just like the previous one, we write an and. Now if 1 is less than the absolute value of x plus 4, that means the absolute value of x plus 4 is greater than 1. And keep the and coming down, and that means this is okay, so we leave it like that. I just want to have the x on the left side and the constant on the right side, so I switched it around. So 1 is less than that, it means that this is greater than 1. And we have a greater than, so I go to negative of x plus 4 is greater than 1. A greater than is an or. And the positive of x plus 4 is greater than 1. And here's the and in between. So we're coming down the middle. So we have the negative of x plus 4 is less than 6. And less than, and I'm going to write a small and here. A less than is an and. So a less than is in between and. So it's positive x plus 4 less than 6. If you notice the way I did it in the previous unit on absolute value with inequalities, I always go with the same sign, greater than is a minus and a plus, but greater than is an or because it's on the outside. And I do the same thing with a minus and a plus, less than, that's a less than 6. Notice less than 6, that's a minus and a plus. But again, greater than is an or, less than is an and. So we keep solving these. So that's the negative of that. So x plus 4, and we're going to divide by negative 1. So that makes it less than negative 1. And we don't, that's just an x plus 4 is greater than 1. Again, we do an and the negative, this is x plus 4, multiplying by negative 1 or dividing by negative 1 makes that a greater than, makes that a negative 6. And this, the plus don't change. Continue to solve. Now, I'm just going to skip a line here to give us more space. So x is less than negative 1 minus 4. Or x is greater than 1 minus 4. With an and x is greater than negative 6 minus 4. Move the 4 over, make it a minus. And x is less than 6 minus 4. To simplify each of these, x is less than negative 5. Or x is greater than negative 3. Big and x is greater than negative 10, small n, x is less than 2. So now we have this one worked out to here, and we have this one worked out to here. There's an and. So let's call this one A, because I'm going to do a graph on this, and call this one B. So this is the A. So we have, that's A, and this is B. So you see the two graphs. So what I'm going to do is use a red pen and mark A first. So before I do that, excuse me, I'm going to put all the numbers in. So x is negative 10. I got a negative 10, negative 5, negative 3, 2. So let's put down a negative 10. Then we put down negative 5, negative 3, and a 2. And I don't have to worry about the spacing, just as long as they're in the right order. So it says that, let's do A. Let's mark A in, what color have I got it? Red. So A, x is less than negative 5. So less than is a hollow dot. There's no equal sign. Less than is to the left. And x is greater than negative 3, not equal to negative 3, but greater. So you go to the right. So that's A. A is, let's say A is in red. And let's use the B in black. So the B, x is greater than negative 10. So greater than negative 10 is not 10, but greater than negative 10 is all the way over like this to the right. And x is less than 2 is not 2, but less than. Less than is to the left. There it is. So if you look at this, the red is A, And the B is, this is the B, it's the black. In the black, in these two, which is an and, we have in B, these are the numbers right here, the shading. So all the values of x between negative 10 and 2 satisfies this inequality right here. So if you take all these numbers between negative 10 and 2, it'll make this inequality true. And if you got A is an OR, so we have all the numbers greater than negative 3 and less than negative 5 will make this inequality true. But between all of them, and here's the key, between all of them, or both of them I should say, we have the intersection with, notice as I come down, I'm going to use a green, I have here and here. So between the two different inequalities, so these are all the numbers that are between all of them. So we have negative 10 less than x less than negative 5, or we have negative 3 less than x less than 2. So these are between all of them. So I'm doing this as an intersection like this. So these are the answers, and if you want to make that open bracket negative 10 comma negative 5, or open bracket negative 3 comma 2 open bracket, that's the values of x that'll make this inequality true. And if you wish, you could also do it another way. Instead of graphing, you could pick up a 3. Between negative 3 and 2 we got a 0. Between negative 3 and negative 5 we got a negative 4. Between negative 10 and negative 5 we have a negative 6. And to the left of negative 10 is a negative 11. So we can go through and put 3 in and see what happens. We can put the 0 in to see what happens. And if you do, you'll see that I'm just going to put in the ones that fit. So I'm just going to put in the negative 6. So if x is negative 6, put a negative 6 in here, and I get 1 less than absolute value of negative 6 plus 4 less than 6. So I took the negative 6, subbed it in here, and that gave me, that's negative 6 plus 4 is negative 2. The absolute value of negative 2 is 2. 2. So 1 is less than 2, less than 6. That's okay. So we can see that these right here, these are the numbers that make this true. And we also look at the 0, x equals 0, and sub 0 in here. 1 less than 0 plus 4 less absolute value less than 6. So I put a 0 in here, and I got less than 0 plus 4 is 4. The absolute value of 4 is 4. So 1 is less than 4, less than 6. That's true. So again, just to illustrate, these are the ones that make it true. This interval here, remember, is hollow, no equal signs. If you didn't do the graphing, but you did the shading like here, putting in the number. So if you put 3 in, this inequality would be false. If you put negative 4 in, this equality would be false. If you put negative 11 in, this inequality would be false. So these are how I do this question. Again, repeat, unique, this is unique. Negative, positive of this with an OR. And this is a negative and a positive of x plus 4 with an AND. But you don't change anything. The only thing that you do, you put the negative and positive, and you do an OR for greater than, an AND for less than, and it works its way through. That's the way I taught it in the previous unit on absolute value. So that brings us to the end of the video, and again, if you like my video, click on the like button, click on the subscribe button if you want to be a subscriber. Visit my math website, www.mathfullyexplained.com, to find more information about me, my video, and my content. And that's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye bye.